This video introduces inverse sine. Consider the graph of y equals sine of x. You'll notice that this is not a one-to-one function. If we restrict the domain to just the interval negative pi over 2 to pi over 2, this restricted portion of the function is one-to-one and has an inverse. We know that inverse functions have to be one-to-one, so basically we're just taking sine and we're forcing it to have an inverse. And the way that we force it to have an inverse is by restricting the domain to be just this one-to-one section, negative pi over 2 to pi over 2. So here's our notation for inverse sine. It looks like a little negative exponent of negative 1, just like we used when we're talking about any kind of inverse function, f inverse of x, so we're using that exact same notation, but the trig functions have a second notation. Instead of using the exponent of negative 1, which again, it's not an exponent, it's just a notation, sometimes they use arc in front of it instead. So sine inverse of x or arcsine mean exactly the same thing. Personally, I tend to use the negative 1, it's less writing, but I'll use both interchangeably just so that you're comfortable with the notation. All right, so y equals sine inverse of x, or y equals arcsine of x, means that x equals sine of y for y in between negative pi over 2 and positive pi over 2. In other words, this inverse sine means y is the number in the interval negative pi over 2 to pi over 2 whose sine value is x. Thus, we can write y equals sine inverse of x as sine of y equal to x to evaluate it. So basically, when you're looking for an inverse trig function, you're looking for an angle. And the angle has to fall for sine in between negative pi over 2 and pi over 2. So what's the angle that gives us this particular number? The range of sine of x, looking at the graph, is negative 1 to 1. So that means that the domain of sine inverse is negative 1 to 1, and its range will be negative pi over 2 to pi over 2. Remember, with inverse functions, we interchange the domain and the range, so that's why it's happening here. Again, I don't think this is necessarily something you need to memorize. You have to memorize what the graph of sine looks like and all the characteristics of the sine graph. And you already know this information about inverse functions, so just put those two things together. You know what the domain and range of sine is, you're just going to interchange them for your inverse sine. So let's find the exact value of y. Our first one saying that y equals sine inverse of negative square root of 3 over 2. Basically, the question is, what angle between negative pi over 2 and pi over 2 does sine equal negative square root of 3 over 2? So that's basically what we're doing here. Square root of 3 over 2 is a familiar number to me. I know that that is the long side of a 30, 60, 90 triangle. So that tells me, let me draw my picture here, that I'm looking for a triangle in either the first or the fourth quadrant, right? Because that's my negative pi over 2 to pi over 2. First or fourth quadrant that has a sine value of negative square root of 3 over 2. Well, out of those two quadrants, sine is only negative in the fourth quadrant. So I know my triangle's in the fourth quadrant, and the y value, the sine value, is the long side. So I'm going to do short side, long side, make a triangle. I know that I'm going to have a 30-degree reference angle there because this is a 30, 60, 90 triangle, and the large angles across from the large side. So now I just have to figure out what that angle is in radian And I got to make sure that I list it so that it's negative pi over 2 to pi over 2. 60 degrees corresponds to pi over 3. So basically we've gone negative pi over 3. So y equals negative pi over 3. It would not be correct to give an answer of 5 pi over 3, which I know is coterminal, because it does not fall in this range of negative pi over 2 to pi over 2. All right, next let's find y equals arcsine of 1. Oh, here we have the question. What angle between negative pi over 2 and pi over 2 does sine equal positive 1? I'll draw myself a picture. Sine is 1 at only one place on the unit circle, right here. And to label that in between negative pi over 2 and pi over 2, we get y to be equal to pi over 2. So let's talk about the graphs of the inverse sine. To get the graph of y equals sine inverse of x, we're going to reflect the graph of y equals sine of x about the line y equals x. That's just one of our basic properties about inverse functions, is that they're symmetric about the line y equals x. So here we have our basic sine. And then here is y equals x, and we just reflected it. So here's kind of a zoomed in breakout picture of the graph. Things we can say about the graph of the inverse sine function: it has a domain from negative 1 to 1 and a range of negative pi over 2 to pi over 2. Y inverse of x is increasing and continuous on its domain negative 1 to 1. Its x-intercept is the origin as well as its y-intercept. And this graph is symmetric with respect to the origin, making it an odd function.